Hey everybody, welcome back. Coop here with Random Acts of Tech, and today we are working on a little side project. My cat has the unfortunate habit of jumping up on the bathroom counter and drinking from the sink anytime we turn on the water. To remedy this, I figured that I would build her own drinking bowl with a fountain inside it. And to make it even better, I'm going to make it motion controlled. Now to do this, I'm going to need several items. I think I have all of those items here. However, I may find as I go that I'm missing a few things, and we'll cross that bridge when we come to it. The first thing we're going to need is the actual water bowl itself. I am using a Glad Tupperware container. You could use anything you like. We're also going to need some type of water pump. You could use an aquarium pump or a pump like this that I got from Home Depot. This is actually a pump to recirculate the water inside a ceramic cutting saw. This cost me about 15 to 17 bucks from Home Depot. You're also going to need some rubber hosing that fits over whatever outlet is on whatever pump that you have. You're going to need roughly half-inch in diameter piece of PVC pipe. This is what we're going to use to give the fountain head shape. This along with a 90-degree and a 45-degree coupler that fit whatever size pipe you decide to get. We're going to need to cut it down, so I got a PVC pipe cutting tool for about $5 from Home Depot. And then you're going to need some PVC cement to put all these things together. You're also going to need at some point a few ring clamps, adjustable ring clamps, to hold some of these things down. For some of the holes that we're going to make inside the bowl, you're going to need to get some kind of caulk to make sure that none of the water leaks out. For the electronics portion of this project, we're going to need a couple of items. The brains, the most important part, is our microcontroller. I am using an Arduino Pro Mini microcontroller. I got this off eBay for about $4. You will need to program this. I've already pre-programmed it with the software that we need to run our pieces. That's a little bit more of a complicated process, and that's for another video. You are also going to need an ultrasonic distance sensor. This is what's going to trigger the fountain whenever something approaches the bowl. You're also going to need a relay. This relay needs to trigger at or below 5 volts, and it needs to be rated for 120 volts at 0.2 amps. You're also going to need to convert our main power supply, which is at 120 volts, down to 5 volts, which is what our microcontroller wants. For that, I just took the insides of a phone charger. This is an old Motorola phone charger. I just took the insides of it out so I can hook up our power from the wall here, and then it'll give us 5 volts to our microcontroller, which is what we want. I'm also using a couple of small breadboards, so we have to do as little soldering as possible for this little side project. There may still be some things we have to solder together, but this will keep that down to a lot. We also don't have to make any kind of custom circuit boards for that. So these are all the things we need. Let's get started. All right, the first thing we're going to do is we're going to cut our PVC pipe down to size to make it the correct height that we want it to be. This doesn't have to be an exact measurement, just kind of however high you think that you want your fountain to be. I'm just going to kind of look at it and say that I want the fountain portion to be about this high. And I'm just going to hold on to the spot. I'm going to take my PVC cutter. I'm going to clamp it down so it starts to dig into the PVC, and then I'm going to rotate it. And then I'm going to clamp it down a little bit tighter, and then I'm going to rotate it. Clamp it down a little more, rotate it. I'm just going to keep doing this over and over again until you eventually get all the way through your PVC pipe. As you can see, you're now starting to kind of groove out where your cut is going to be. It's going to get a little bit tougher as you go. If you need to get a tool or something to tighten down the knob, that'd be acceptable. I'm just going to use my shirt. I got it there, why not? And then eventually, you'll hear it crack like that. That means you're all the way through. And then you should just be able to rotate it around once, and there you go. Cut open. So now I have a piece that's going to be the correct height. Now, in order to get it to be the right angle, what we're going to do is we're going to apply the 90-degree angle coupler on the top. We're going to cut another small piece of pipe to fit it into here, to that 90 degree. Then we're going to take the 45 degree and put it right over top of this other small piece that we're going to cut right now. So I'm going to go ahead and cut a small piece, roughly inch to an inch and a half long. All right, so now I have my little inch to inch and a half piece of PVC that's going to go in between my 90-degree coupler and my 45-degree coupler. Now there's a possibility if this doesn't fit, that because the cut bulges out the edges a little bit, you may have to really force it to get in there, or you may even have to go down and sand these edges down so that it fits inside the coupler. We're going to find out if we have to do that right now. So it does fit in there, however, it's not fitting very snugly because you have that little lip on the end. So what I'm going to do is I'm going to get some sandpaper. We're going to sand it out a little bit. So something that I noticed is that the piece that I cut is a little bit too long for what I want it to do. So what I'm going to do is I'm going to take this leftover PVC that I have, and I'm going to cut a smaller piece off so that the two couplers match up nicely. Now I have a much smaller piece that's going to match these up really nicely. But now what I have to do is, since the cutting tool bowed out the edges a little bit, I'm going to sand them down so that it fits nice on the inside of the couplers. So this new piece that we've sanded down fits much better inside this coupler. So what we're going to do now is we're going to take our PVC cement and we're going to cement these in place. Now, to get our tube fed through our pipe, to get around this curve, what we're going to have to do is first feed some wire through the PVC pipe. You have to kind of bend it a little bit to get it to go around our 90-degree curve there. Play with it for a little bit. Eventually, you'll get your wire fed through there. The next thing you're going to need to do is take your tubing and start feeding the wire on the inside of the tubing, and then slide the tubing up into, you may want to pull out a little slack, and then you're going to slide your tubing inside the PVC. And what this will do, when it gets to the bend, you'll be able to kind of tighten your wire just a little bit, and that'll help the PVC, the tubing, make that 90-degree turn. And there we go. We get our tubing fed through. Now we can pull our wire out. Now we're just left with this tube coming through our PVC pipe. So we need to kind of pull it back a little bit until it matches up with the end of our PVC pipe. You could put it back a little bit more if you wanted it to actually drip down the edge of the pipe, but that's something you can also adjust later on. So what we're going to do now is we're going to basically attach this PVC pipe in the corner. We're going to have to do a little bit of finagling here to make sure that it doesn't angle back like this. We want it to angle forward so it falls kind of in the middle. Peanut butter cracker time. I don't know, what does it seem like? It's been long enough to deserve a break. But real life time is a little longer than video time. I've been here a long time today. So now we have attached our spigot to the corner of our container. It's fairly secure. It will still slide out, and then you kind of have to loosen it and retighten it. So what we're going to do eventually, once we get it kind of all put together, is we're going to take some of that caulk and we're going to caulk the bottom where the tube touches the bottom of the bowl, because then that will give it a little more structure along the bottom. But it's staying fairly well on its own, just as it is. And because this clamp is so high, we are going to caulk this, but we're not really going to run a risk of it leaking around that spot. So the next thing we're going to do is we're going to find a placement for our pump and cut our tube to meet the appropriate length to meet this little spigot here on our pump. So we're just going to place it inside a little bit and find kind of a good spot for it, where we want it to be. It could really be anywhere because the tube is running to it. You got to keep in mind though, this cord has got to run back and it's got to come out the back of the fountain so that we can get power to it. So I actually think right about there is going to do it. So now we can take our tube and we can cut it to the appropriate length to meet our little spigot there. So it's coming along. We got the insides kind of pretty much laid out here. The next thing that we're going to do is we're going to cut this cord because we actually need this power to go through our electronics before it goes to the pump here. So we're gonna cut the cord, and then we're gonna make a hole for our cord to go back through, and then we'll start on the electronics part. All right. Well, now what we've done, we've cut a hole here. We've pulled our cable through. We can now start to work on the electronics. Basically, we need to take this end that's going to go into the wall, and we need to split it off. Part of it we're going to take, and we're going to send to our little transformer here. That's going to take the 120 volts and take it down to 5 volts to send to our Arduino. We're then going to hook one leg of the power directly back up to this pump. The other leg we're going to send through our relay so that there's only power going to the pump when our relay is tripped. Then we're going to have to put our sensor in so that when something gets within a certain range of the sensor, it trips the relay and sends power to the motor. So the first thing we're going to have to do is strip all of these cables. We got to cut up in the sheath and get down to the 3 cables that are on the inside, the live, the neutral, and the ground wire. So now basically what we're going to do is we're going to touch this, which is from the motor, and this, which is from the wall, ground to ground, and we're going to send live to live. We're actually going to solder those because we want it to be a nice secure connection. Then what we're going to do is we're going to take one line from our neutral, one line from our live, and we're going to split that off. I'm just going to solder some short pieces of wire off of this so that we can get power to our Arduino. We are also going to take off of this power that we take from our neutral. Off of that directly, we're going to take a line that goes through our relay. So our neutral is going to have 2 pieces of wire coming off of it, and our live is going to have 1 extra piece of wire coming off of it. And then we're actually going to take an additional piece of wire off of the neutral from our pump. So I'm going to go solder these together. I'll come back and we'll take a look at what it looks like. Okay, so I have soldered some of these cables together. Just to give a quick rundown of what I've done here. I have taken the ground and the hot leg of this cord that I cut in half and soldered it directly to the ground and the hot leg of the pump itself. I have taken a little extension here off of the neutral and the hot leg and run it into this little circuit that we took out of a phone charger so that we can convert this 120 volts that's coming in into 5 volts right here. We have now 5 volts DC that we can run to our Arduino board, because our Arduino wants 5 volts and not 120 volts. It also wants DC and not AC, which is what comes out of the wall. So I have gone ahead and soldered this little power converter that we stole onto our circuit here. I have also taken the neutral that goes from this cable that we're plugging into the wall into the pump, separated it and attached these 2 little extensions on it. So if we were to plug it in and touch these together, it would complete all 3, the ground, the neutral, and the hot, directly to our pump, and it would turn on if we just touch these wires together. But we're not going to do that. We're going to run these 2 wires through this relay. And when the relay closes, it'll close the circuit and cause the pump to go on. Our relay is going to be triggered by this sensor. We've got this sensor that's going to constantly measure the distance of something in front of it. And if it gets close enough, a predetermined number of centimeters that I've programmed into the board, which we can change, it's going to send a signal to the board saying that's close enough. That is going to send the signal to the relay, closing the circuit. When that circuit closes, the pump is going to turn on. When the pump turns on, the water flows down this spigot that we have made. And then when the object that is in front of the sensor goes far enough away, it's going to shut off. And that will complete this project, other than tidying it up. Now, there is a lot of, like I said before, programming involved in this Arduino that I will try to put into another video for you guys, so you can see exactly how the programming goes. And also the wiring up of this is a little more complicated too, so I'm going to try and put that in something separate as well. But I have gone ahead and wired up our sensor to our Arduino board, and then our Arduino board going out to our relay. Now the only thing that I need to do is I need to wire in our neutral that's going to go through our relay to give us the switch, basically, for our pump. And then I need to give our Arduino power, and we should have a working system. So what I'm going to do is I'm going to move all these cables and stuff around the back, just to clean everything up. Notice that I'm working with this unplugged. I don't want to plug this in and send current through my finger, so it would not be good. I'm going to take one side of this neutral line and go into one side of the switch in our relay. I'm going to take the other side and go into the other switch on our relay. And that should give us the bridge between our neutral from our power and our pump. Now I'm going to take our DC power that we've converted to 5 volts. I'm going to put it into our volt input and our ground on our Arduino board. I'm going to plug it in, and I'm going to see what happens here. So the light comes on our Arduino board, which means we are getting power to it. I can tell, I don't know if you can hear it, but when I get close enough, you'll hear the relay actually switch on. So when I get close enough, that relay switches on. I can also see, I'm not sure if you can see it, when I get close enough, the pump kind of vibrates a little as it turns on. Which says to me that we're functioning here. So what I'm going to do is I'm going to put some water in here. I'm going to have to be careful because we still haven't sealed up this hole. If we are working, I'm going to seal the hole. I'm going to give us a little extra room on these cables and try to neaten them up a little bit so we can bring the sensor around to the front, because obviously we want the sensor to be on the front so that whenever the pet, in my case a cat, walks up to the bowl, it sees its feet or its body in front of it, and then the water will turn on. So I'm going to go put some water in here, and we'll see if we're working. All right, so I have filled this up with enough water to cover the area that it needs covered to function properly. I've also gone ahead and extended these 2 wires out so that we can put our sensor right up here at the front, just kind of temporarily. I'm going to plug it in, see if it works. All right, we have power on our Arduino, so we know that that's being powered. And we will simulate a cat coming up looking for a refreshing drink. Hear a little switch, and there it goes. It's perfect. The cat is within 4 centimeters. It's going to flow, and then if she steps away, it turns off, so you're not wasting power. This is pulling very, very little power, so you don't have to worry about that costing any extra. This is done, folks. All we have to do now is kind of clean it up and package it in whatever manner you see fit. It's fully functioning the way it is. You could leave it just like it is, except you probably don't want it to splash down on your electronics that much. But there is, with this particular pump, a little knob down here that you can turn and have it pump less water, which may make it a little. Well, you got to have more water than that, apparently. But you can find maybe a happy medium where it doesn't gush out, but you're still getting enough to get a nice drink. Somewhere there looks nice. You're not really splashing all over your electronics. So you also have the option of kind of turning this a bit to get it where you need it to go. But other than that, we're all set. So I'm going to seal up some of these holes. I'm going to clean some of this up, and we're done. I'll see you next time. Until then, make something.